Hello, welcome everybody. Today I will tell you a bit about different security tests that we can run against our products. But hopefully I will not lecture you about different features and boring options. I want to tell you a real story of the attack that I took part. And on this example, I will try to show different approaches, differences between different security tests. A few words about myself. My name is Paweł Krzywicki. The surname is not crypted, it's just Polish, because I come from Poland. I'm working currently for Intel as a security researcher and red teamer. I used to be a red teamer for a number of years, and that's used to be my dream job. I'm playing right now more on defensive side, and it's much harder, really, but it's also less fun. I used to be also a project manager, so hacking executives for resources, that was also a part of my life. And I always, during my 20 years of IT career, was developer, and reverse engineer would help me also to get into red team. And as I said, that's my dream job, and you will see this on my presentation. So first, disclaimer. Everything you will see on this presentation, it did happen. Just the names of the tables, servers, columns, and so on was changed, hopefully in all places, so no real data will leak. So what I will show? First, I will show what kind of the approach I would like to show you for the comparison of different security tests. What does it really mean? What does it mean to choose what kind of tests do we want to run against our product? Later on, I will drill to the most exciting, at least for me, part. So what was the target, what we tried to achieve? And then I'll guide you through all the paths that we took to achieve our objectives of the tests, all of the mistakes that we did, and hopefully we'll come to the happy end. And then hopefully I will use this approach to compare different security tests that we can run. So let's take a look. We can run a number of security tests. I have grouped that into 3 categories. So under white box, I mean just the regular code reviews. We can have black box, so we'll treat the product as we do not know the code, but we still try to check whether it works, whether it has some security objectives that we claim it to be. And then there is also my beloved red teaming. But whatever test we take, at the end of the day, we'll get from the tests the findings. And the question is what we do with the findings. Hopefully it's not that we put it into the crash and just release whatever we have, although I've seen this approach not more than once. But if we go to the findings and we take a look at them, we have to think whether we want to spend money or other resources like time, people, to fix them or not. And what can help us with deciding which findings are relevant and which are not. I wonder whether you have seen any of the reports from penetration findings or from security code review. Who has seen such things? Okay, I've seen a number of hands. The biggest report that I have seen, it had 27,000 of pages. And the company who got this report, fortunately not from us, asked us as a red team, what does it mean? So sometimes it comes to that we have tons of findings and what we can do. One of the things that we can do and what the management understands is that we can try to apply the risk associated with the findings. And when we want to impress the executives, the management, we can explain the risk in terms of numbers, because the numbers, that's what you do not easily question. So we can think about a funny formula, and fortunately it's not formula that will bring out the focus to this presentation, but what we can do with this formula. First we will check what is the severity of the finding, of the security finding that we report. So severity, it means what is the damage if such finding will be exploited on production. Then we can count in also likelihood. What is likelihood that it will happen? Maybe it will happen just for 1 request in a million, So we might think, okay, we'll just keep an eye on it, but we will not fix it at this time, maybe later. What if it's quite likely? Maybe we should bring our attention and fix it much sooner. And the third component is the detection difficulty. Because sometimes we can find very clever way to hack the system, but we can think that if such hack leaves a lot of traces, then we can find it easily and hopefully react quickly. But if we report an issue that ends up in a serious hack and which does not leave any traces, then the problem is really serious. And that's why we want to express that with a number, so it will be much more easily digestible by executive and management. So bear in mind these three categories which we want to get from the security tests. So hopefully our testers, our security testers, will not only report that they found a funny way, exciting way to hack our system, but they will also be able to show us what is the severity, what is the occurrence and detection difficulty of their findings. So let's take a look at the landscape that I would like to use to make a comparison. So under white box test, I mean just the statistical source code review. Under black box testing, I mean the penetration testing. So we bring the test instance of our product. We show what are the interfaces. We show even the internals of our code and give the pen testers full access to the environment and let them unleash all the tools that they can use. Under red teaming, I mean that we are defining for the red team just these three things. So first, what is a threat actor? So who they should simulate? Whether we as an organization are afraid of maybe organized crimes, maybe we are afraid of APTs, so maybe state-sponsored hackers, maybe we are just afraid of our internal employees who might be disgruntled because of some job cuts. So first we define threat actor, then we define the target. And the target is very specific. So it means that, for example, we can define that if our organization is a bank, then we are typically afraid that the personal data of our customers will leak, or maybe the credit cards which are stored in our systems will leak. So as a target, we specify very detailed way, for example, specific table in the database which contains such data, or maybe we define specific file share and the files where such data is stored. And then the third component of the red teaming is that under the scope, we define the whole production environment. And production, it's very important, because as a red team, we don't want to get into discussion, okay, it was just a test instance, nobody cared about the logs, so that's why you were able to hack it. So then any findings from the red team would become irrelevant. So I wonder how many of you did or took part in a static code review? Okay, a lot of people. And how many of you took part or were under penetration tests? A bit less. And how many of you experienced red teaming? Even less. Hopefully the other people were also a subject, but the red team did the good job of hiding their activities. Okay, so here we have the landscape, and let's try to find out what the attack we did. So as a target, you can see on the right-hand side, there was a database, and we were asked to put very specific data into one of the tables, which would trigger the actual payments to some accounts. So if we would succeed, we would put the data into the table, we would put our bank accounts, and then the accounting systems of the company would automatically trigger such money transfer. So that was our ultimate target. But this database had also an application, and in the middle of that you can see application server, which was storing some front end for this application. And this application had all types of access checking and so on. So, of course, there was no direct access to the database. So as a red team, we did not attack the company from outside, but we assumed the initial breach. So we started from the workstation of compromised workstation of one of the regular employees. And what we tried to achieve, of course, we first tried the application server. So we tried to get through the front end, check whether there are any stupid mistakes like leaving for example, object ID in URL, so we can switch it and just change whatever data we can do. But this application went through a number of security tests, and such low-hanging fruits were not available to us. So then we unleashed, as a red team, some infrastructure attacks. So we tried to reach the database directly, but then we hit the firewall because all these layers of application were correctly separated, so there was no direct access to the database itself. So as a red team, we have in scope whole production environment. So what we did as a red team, we started to look around. And when we started to look around, we found on a lonely share file a jar, which name was related somehow to the application that we tried to breach. And this appeared to be crucial, because when we looked further into the jar and associated script files, it seemed to do some operations through the application server, but not with the features that were available for all the users through the front end. So we had a jar. What we could do further? We dived into the jar, and the Java jar files are so kind that we don't have to go through the disassembly process, but we have to simply revert it and decompile it back to the source code. And what we found interesting is that this jar file, it exposed specific additional interface to this application server. And as you can see here, the Java code is making some RPC call and making some XMLs. What interface looks like, I will drill into that further, but the interface, that's just another interface. So we had to drill down what it does, and it seems to be really innocent. It was just returning some dictionaries from the database. Probably it was used to fill some Excel sheets with the data directly from the dictionaries in the application, so nobody would have to copy it in the number of places. What brought our attention is this make list to SQL string function. When we drilled down into that, we found that's just a concatenation of the list elements. So this code just represents that we take whatever is in the list, and we put into comma-separated string, and then we send it somewhere to the server. So if we would run this code through some static code automatic analyzer, then the code is pretty well written. There is nothing suspicious if we do not know the context. But the context was not pretty clear to us, so we started to think what we can do. And let's break for a moment here. So we found a jar file, we found specific code, which seems to be pretty promising to us as a red team. But let's take a look how we would approach this code if we would run into these three categories. So if we would do the static code analysis, we would just report a bug. We would think whether it is informative or low priority bug. Let's just developers deal with that. Hopefully, the developers will know all the context and will figure out whether this code needs to be fixed or not. When it comes to penetration testing and red teaming, that's just the beginning. Yeah, that's the entry point. Maybe it will prove successful, maybe not, but it's worth to exploit it. So, what is this XML-RPC invocation that we saw in the Java code? We can trigger it easily with just a curl command. All we can do is add the HTTP header content type text XML, and then in the post, we can specify specific XML. And within this XML, we provide the method name that we want to call. In this case, it's getEquipment. we can specify the parameters. And the parameters is where this list concatenation was used. So we tried to run it and put the output into XML file. Why it's important, I will tell you in a moment. When I was showing this first time, a friend of mine told me, okay, but where is the host name? And then I said, yeah, at least here I anonymized this slide properly. So, what happens next? We can also provide some parameters here. So, for example, we can put number 100 or put any other comma-separated values. And then we can filter out the equipments for the type 100. And we can also redirect the output to the file. And if we take a look at the file, it will look like that. That we are getting the results from the database, that there are 3 properties for every row returned, and they are just some unknown for us values. Maybe they are important, maybe they are not. They are definitely not related to the payment that we would like to achieve, but that's just the beginning. It means that we have a way to execute something on the database to get the results without any authentication, because all we specify here is just an XML. So that sounds promising. So what we can do next? Next, we can think about what happens in the background, because that's the XML that we are sending. It's being processed by some Java code, but at the end of the day, we know that it hits the Oracle database, so then there is definitely some SQL on the way to the database. So we can think about how these parameters used for filtering are being used in SQL. So at the previous presentation, I found out that not all the people use SQL, so it was pretty surprising for me. But some people, if they operate with databases, they just stick with object relational model, so there is no need for SQL. But at the background, if we use relational databases, SQL, that's what happens. So a bit information about simple SQL select statement. If we have a table which has particular columns and rows, then we would like to select just a subset of the data. We can do some filtering. So what we execute on the database is a select statement. In select statement, we define what columns from the database we would like to fetch. And then we can also specify which particular rows we would like to fetch from the database. And we can tell in the where clause that particular columns should be equal to particular number, but we can also use the in phrase. And as you can see, then we can supply a comma-separated values. So the returned result will contain only the IDs which were listed. So comma-separated values, that seems pretty promising, because it looks like it's something that Java code was tried to achieve. So what we can do with that? We can think that the equipment types that we can supply in XML is a comma-separated value. And we can think about, okay, so we have a string with comma-separated value, so how it can be processed on the database side. We can think that probably it is being concatenated with the select statement that I have shown before. So there is some select phrase, then in phrase, and then the parameter that we have supplied from outside is concatenated, and then just the ending bracket is added. And then such newly formatted string containing the query can be executed. So this is the assumption, that's the educated guess. So how we can prove whether this educated guess is correct or not? So we can try to put under this equipment types something else that we know that will be actually interpreted by the database, and some more logic will be executed. So for that, because we know that it's Oracle database, we can use something like the code statement. And the code statement, it's a bit like a switch case from other languages. So it evaluates first expression, and according to the expression value, it can return different results. So for example, if we decode column 1 value, and if it is 100, then it will return CRT. If it is 101, it will return high. At the end, if the column value is not listed, then it will return unknown. So we can also try to find out and use such a phrase like select one from dual. Dual is just an abstract table on the Oracle. It is not really a table. It's something that we can just use as a table name. And this statement, select one from dual, should always return 1. And we can put it under the code evaluation, and we should get some results. So the point is to just execute anything that should be properly interpreted by Oracle. If we succeed, then it means the equipment types is not properly sanitized before concatenated with the rest of the SQL query. So that's the SQL select statement that we would like to execute. So if this code that we are injecting is properly decoded on the database side, that it should shrink into just 101 value. And what it means? It means that we can supply into this XML the code statement in the way like that. And when we execute it, we got the output. And the output, you can see that we redirected that into equipment 101 XML with I suffix. It appeared that the output is exactly the same like we did for 101 filtering. So we proved that it works. So we can think what we really achieved. We have extracted 1 bit of information from the database because we executed the code which would work differently, whether it would be returning 0 or 1. So 1 bit of information, that may be not a big finding, but we can think what else we can do with that. So instead of just looking for returning 0, 1, we can, for example, select all the attributes from the user privileges for the user that is running all these queries, and we can check whether this user has admin option. And this is 1 bit of information, if this admin option is 0 or more, but that's pretty significant information that we can take from the database. We can also run more complicated query. For example, this query, it checks whether there are Java packages enabled on the Oracle database, because that's one of the way of escalating privileges on the Oracle database. And that's also what we can get significant information using just 1 bit, here really 2 bits, as you can see in the code, of information. So not much, but still some additional information that we can get because somebody left XML interface unauthenticated. So what different security tests would do? In the static code analysis, those guys would be already on the vacation or on interesting developers conference because they already reported the bug. But with pen testing, that's the beginning of the story. They have the test instances, they have unleashed all their tools, the tools like SQL map, which would use this 1 bit of information per query and just get all the data they could using this particular user connection. With the red teaming, we have to think that we are simulating an attacker. An attacker will not unleash all the tools just to get caught. They have to think carefully and just think about the ways that would do something similar, but silently. So we can try something else. We can try something like SQL Union. And SQL Union allows us to fetch the data from 2 different tables. So we have seen that we could get the data from the equipment table, but it was not really interesting. Maybe we could try to use the union statement to fetch some additional data from different tables. So what the union does, when we add union statement, then we can specify additional select from a different table. We just have to make sure that the column names returned by this additional select matches the first one, also in terms of the types returned. So if we execute that, we'll get the result, which will look like the result from the first table, but will in fact include the rows from both of them. So let's try to think how we should craft our select statement so we would achieve this union. So here we can see what we think the database does. So what we should do, we should close the bracket. We can just put 0 there so no results will be returned. And we'll add the union. We'll add all those selects. We'll put at the end where 1 equals 1 just to do something that will match the ending bracket. What's important is that we must know what is the number of columns, and we must know the name of columns. What we knew at the beginning is just the XML column names, but when we took a look further into jar files, it appeared that the build process has covered not only the client side of the XML interface, but also the server side. Sometimes I used to joke from that, especially on the security conferences, but a friend of mine told me that, okay, used to be developer, you know how it works. When it comes to deployment, we just put all the code because it's easier to deploy. All the security objectives that might come later, and that's what happened here. So in the jar file, we had also the application server code side, and we can see how the actual database side, so storage procedure, was called, and we can see what were the column names returned by the storage procedure. So using this information, so again, recon, we have crafted this additional statement that used the column names that we extracted from the jar file. So that's how it looks in the XML. So our filter becomes more and more interesting. And when we executed that on the database, then in return we got XML, but not really with the data that we expected. So we ended the SQL command somehow incorrectly. At least we got also information that it was really the procedure that we expected to be called, and that was the prod environment that we were hitting. So in every mistake there is a bit of more information, but it means that our additional educated guess was good enough to select 1 bit of information, but not to properly add a union statement. So what next? With the white box analysis, we can tell, okay, there is additional procedure, it returns strange errors, so we should analyze this particular procedure and report additional bugs. With the black box testing, okay, we have procedure, we know what are the parameters, so we can just fuzz it and take a look where it is breaking and when it is returning interesting results. With the red teaming, yeah, we have to think before we act. So what else we could do? So our initial assumption that it was just the simple filtering proved not to be completely correct because our inject has returned an error. So maybe this SQL statement on the database side is this filtering is put somewhere else. Maybe it is put into the subquery in the where statement. Maybe it is a subquery in the from part of the select statement. So we tried all those educated guesses. So we tried some tricks like adding an SQL comment to quickly end the select statement. We tried to use the double brackets on the assumption that you can see here in this subselects. So we tried also more complicated stuff, like with function statement, which is available in Oracle starting from version 12. But all of these approaches failed. So we tried that a couple of times, but of course we are afraid that it will start to trigger some investigation because it was live system. It's supposed to have live monitoring, administrators which cared about this system because it was very important for the company. That's why the red team was selected as a target for the red team. So we had to think more. So with the white box testing, they already reported that there is probably an issue in procedure, so they don't have to do anything else. With the black box testing, they have test instances so they don't care whether they will fall or not. Even if the database will crash, they will just ask kindly to restore it. But with the red teaming, there is always red team is tempted that if we fail, then maybe we'll get louder. Maybe we'll do something that will be more efficient, and maybe we'll be lucky and we will not get caught. So what we can do? We can use something specific table on the Oracle database called user source. This table holds the actual content of all the objects, including storage procedure. So if we would fetch from this table the storage procedure code, then we would be able to craft our inject better, and this way maybe obtain additional data. But right now we have the access just to 1 bit of information. So how we can use it to read the whole content of the storage procedure? So we can try to select from this table, but we know that we have to wrap it, so we will select just 1 line at the time. We will really select just 1 character at the time, and then we will run it through the code statement, and we will check. If it is A, then we will return the whole list of equipments type 100. If it is something else, we will return the whole list of equipment 101, and we'll try again. So we can wrap it into a loop, but then there is a question that eventually we'll get there, right? It's just the case of a number of queries. But the question is how many queries we need, how much traffic it will generate on the network, whether it will be suspicious or not, whether it will be caught or not. And there is also questions how many exceptions it will raise on the database side. Because even if the regular traffic will not be seen, because this is the live system, the data is flowing in and out of database all the time. But the exceptions, that's something that really stands out in the database logs. So that really can bring an attention of administrators. So we decided that it's not the road that we will go forward with. So what we could do next? With these guys, they already gone to another conference. With the black box testing, if they are brute forcing, they have all the power and resources. They will find what's wrong with the code and they will report it back. With the red teaming, come on, it's not the only way that we can reach what we need because the whole environment is in our scope. So let's do some additional recon. So it appeared that using different techniques, we're able to breach some additional users' workstation. And at the end of the day, we have retrieved this particular storage procedure code just from the code repository. So we still didn't have the access to the database, but we breached the source code repository and really not breached the Git, but simply the code was cloned on some workstations. So using this information, we're finally able to find all these building blocks of the SQL statement that made our previous approaches failed. So what we found is that, okay, in the storage procedure, there is no just a simple select. There is also a cursor used. So that's why some of our approaches attempts failed. We've seen that there are actually 6 columns returned, not 3. It's just 3 that were handled in this XML interface. But when we tried to do the union, then we had to supply a particular number of columns, and we were not aware that there are 6, not just 3. We also found where the injection happens. so where this parameter, this comma-separated list, is concatenated with the rest of the statement. And at least here, our educated guess was right, because you can see that it's in phrase. And then we can see that at the end of the query, there is also ordering. It was also something that we didn't anticipate, and it was messing up with our attempts to breach the database. So using this source code, we are finally able to define what the real inject should be. But here also in the code, we can see that there is a limit, 4,000 characters, so our exploits cannot be too long. So what the real attack looks like. So we can see the whole statement that is being concatenated. So what we can do to make it work in the way that we control. So first what we do, we'll just close this opening bracket so we can start our own stuff. Then we'll deal with this cursor. So we'll just close it, so it will be flushed out of any select statement previously put into it. We'll open it immediately, but for our own statement. And then we will try to select these 3 columns that we've seen in the XML interface. And now we know what types are there. So we know that there are 2 columns which return strings, and the 3rd column which returns numbers. So we'll again try to make a simple exploit selecting from dual just to check whether it works or not. And then at the end we have to deal with this closing bracket. So we'll do it with a trick with this where 1 equals 1. So then the closing bracket will close the one that we opened. So our final exploit has 2 interesting properties. One is that here we can put any select query. As long as we are returning 3 columns, 2 of them are strings and 1 of them is numbers, we can select from any table which is available to the user that is holding this connection. But there is also another interesting thing, that here between closing and opening a cursor, we can put any select statement. So we can put beloved delete tables, but we are red team, we are not breaking the systems of we are breaching, but we are not breaking the systems of our customers. But we can put here, for example, creating a new user in the database, changing the credentials if we have enough privileges. So we can put any SQL statement, not just querying the database. So let's take a look how we can use it. So for example, we can find out what are all privileges of the users, not just by counting them, but actually listing them. So what we will do, we will use the select statement, but we will convert it so it will return 3 column names as they are designed in this interface. And because the last option, it returns yes or no string, that's designed from Oracle, so we will translate it into some numbers. So I've chose arbitrarily 10 and 7. Okay, and then we put it into our exploit. So you can see here that as a parameter, there is a code that was listed on the previous slide. And as a select statement, I have put this one listing the user privileges. So when we executed that, finally, we got not the equipment list, but the actual privileges from the database. And there are 2 interesting privileges listed here. Alter any trigger, create any index. So that's additional lead, additional information that the red team can use to elevate their privileges further. But the main point here is that we switched from accessing 1 bit of information at a time to actually selecting the data from the database, from any table that our user can reach. With that, we can also select some other data. So for example, we can use specific things to Oracle, like selecting user environment. So we can select the actual host and IP address of the database server. So we again translate that to these 3 columns that we have to return. We put it into our XML, and as a return, we will get an XML that will contain the name and the IP of the server. So if we take a look at our security tests, what does it mean if we achieve this kind of result? For white boxing and black boxing, so for static code analysis and penetration tests, they are not so relevant because they already reported the issue. They reported the bug, which should be fixed, and would have stopped the red team from achieving such access. But with the red team, we of course document the finding, but that's not the end. Because we're not tasked with breaching the database, reading all the data, we have completely different target in mind. We have to add some data to the database so it will trigger the payment which will appear on our bank account. That's our ultimate goal. So this thing that we breached the database, that's something that can enable us to do the ultimate thing, but not really the end of the story. But that's something that I will not continue. So as a teaser, I can tell that with this database access, we later on elevated privileges. So we have obtained the database administrator access to the database. Later on, from the point of being able to execute select statement as the DBA, we're able to breach to OS level access. So we ultimately got the access through SSH. Later on, we compromised the server obtaining the root access, and then we were able to spread to other servers all behind those firewalls. But that's a completely different story. So maybe another time, another conference. So what I would like to summarize. What were the results of these three types of findings? So first, if we take a look whether all these tests can find the bugs. Of course they can, because we could spot that the string concatenation and putting that into select statement that might not be the best way to use it. During penetration testing, that's the interface that could also be found, and the issues with it could be reported. With red teaming, we found it, but the point is that with red teaming, we just looked at this one particular function, at this one particular issue. Why? Because we tried to breach the database. We are not tasked with listing all the issues in all the code of all the interfaces. So if we would look just at the bugs found, whether red teaming is important or not, then it's really not what we should expect from red teaming. Because white boxing and white box testing, black box testing, they are much more efficient way to find the bugs. And not just a single bug, but they should find all the bugs in all our code. But as we talked, as I showed at the beginning, number of findings is not the ultimate value that we show later on to the management or executives. We also have to think about what risk is associated with particular finding. So we take a look at severity, likelihood, and detection. And if we talk about severity, as you've seen on the static code analysis, we would be able to find that maybe string concatenation is not the best way to do it, but whether it leads to actual breach of the database, it's pretty hard to tell just from the database code or from the Java code. That's not something. The severity of the issue is not easily obtainable from just looking at the source code. If we take a look at the penetration testing, I have witnessed a couple of times that people were saying, oh, okay, it just happened on a test environment. It would not be really issue on the production because, and there is a number of excuses. So something like denial phase that Troy was talking about during his presentation. But when we talk about red teaming and we show that we breached production database, then there is much less excuses to not treat it seriously. If we take a look at the likelihood, again, with the static code analysis, it's really hard to tell whether it's likely that somebody will breach this interface or not, because we just see the code, and it's very hard to see the whole context. With the penetration testing, it's really possible to show whether we can breach with this particular issue or not. It really depends how much time we give to our pen testers and how much they are passionate about their work. And what we achieve, we can take a look how much effort they spent to actually breach, in this case, the database. With red teaming, it's not just the effort that we will see. We'll also see it through a specific threat actor that red team was tasked to simulate. So hopefully, if our red team is mature enough, we'll be able to tell whether it was achievable by state-sponsored hackers, whether it will be achievable by cyber criminals, because red team can tell that, for example, to obtain this access, they had to use some cracking machines which would not be available by a regular employee or only available to really well-sponsored or desperate cyber criminals. So that's the additional information that red team brings. When it comes to detection, we have much more information from red teaming, the information which is not really available in other security tests. Because with code analysis, nobody really cares whether some information of that is some issues during the breaching can be found in the logs or not. With the penetration tests, it's also the same, because even sometimes we take a look at the logs which are produced by pen testing team, but because they used a lot of tools and they unleash a lot of scanners, then the logs can be really messy and it's really hard to get any observable data from that. But with red teaming, it's live, it's production. They simulate the actual attackers, so they should have been detected. So the database administrator should have seen that there is a strange exception in their log files. They should react, and I must tell that in a couple of situations, I was actually cut off the database because administrators spotted that. But that's the human factor, and that's something that can be obtained only with the red teaming. And in such cases, when I was caught during such exploitation, we were able to show, okay, you have an issue with this interface, but you have also a very strong administrative team who is able to monitor their system efficiently, and they are able to code such issues. So this gives additional information to our customers where they should spend resources, which interfaces they should fix first. And when it comes to resources and money, it also, you can take a look that all of these issues could have been found pretty quickly. Maybe during design phase, but definitely during code analysis. And when it comes to the cost, I was a bit joking that the people from static code analysis, they are already on the developers conference and so on. But because they were able to point out these issues pretty quickly, efficiently, and without much cost. So it means that their budget could have been spent on the developers conference. But with pen testing, the cost was much higher, and with red teaming, we spend a lot of money on red teaming, and if we think that we will just have 1 or 2 bugs found in the systems, maybe that's not the wisest way to spend money. And that's why it's important that if we do red teaming, we do not expect just the bugs to be found. We have to think about all this likelihood and detection mechanism. That's what we should expect from the red team. Not just the breach, but how our organization reacts to all of these actions that red team does. So these are my thoughts about all these different tests. In all of these kind of categories I took part. Red team was closest to my heart, but right now I'm more to the light side of security protection. But hopefully these thoughts will also give some insight to you and you will be able to use them in your jobs. If you have any questions, please ask now or find me later at the conference. So during the red team engagements that I took part in, it were typically 2 to 4 weeks. So when we started from initial point of breach inside the company, that was enough time. And in this particular case, it took me about a week from initial finding of this jar file, so analyzing the jar, so analyzing the Java code, then trying pretty quietly all of these interfaces to the ultimate bridge. And during this 1 week, I was focused on this database interface. But for example, this database code that was supplied by another colleague from the team, she was actually looking at some other accesses, and she was able to breach the workstation where the database storage procedure code was found. So it was a 1 week time, and ultimate success was obtained because of 2 of us working together. Okay, so thank you very much, and see you on the conference.